Hey guys, Miss Gregory. Mid-Chapter 8 review, lessons 8.1 through 8.4. What you need: your math workbook, open to page 614, notebook paper to take notes, and a pencil. Alright, lesson 8.1 goes over function tables, covers workbook pages 579 through 582. Inputs typically are the X, outputs are the Y. Listed as an ordered pair, X comes before Y just like in the alphabet. You usually crawl across for the X and you walk up for the Y. You also need to know function rule. You will see all three of these words listed under vocabulary highlighted terms in your workbook on page 580. Lesson 8.2 covers function rules. You can see workbook pages 587 to 590. The main vocabulary words there are the arithmetic sequence, which means you're adding the numbers in the sequence, or the geometric sequence, you are multiplying numbers in the sequence. You have to be able to tell me which type of sequence it is and show on the table. Lesson 8.3, functions and equations, workbook pages 595 to 598. Being able to find the function rule, write it in words and as an equation. For example, you need to also be able to show linear function. Does it make a straight line? If you connect the dots and it makes a straight line, it is a linear function. Alright, lesson 8.4, multiple ways to represent functions, workbook pages 603 to 606. Again, here are the four things you need to be able to show. You need to represent the function in words, in a function table, as an equation, and even an expression, and in a graph. So, for example, if the pattern or the function rule is to add 2 to the input, written in words, add 2. As a function table, you've got inputs, you've got outputs. Typically the input's X and the output is Y. So if you are putting in 1, 2, or 3 and adding 2 to the input, your outputs would be 3, 4, and 5. Typically the equation, unless they tell you a certain variable to apply, then you're going to always say Y is equal to, Y standing for your output, is equal to the input. And something is happening to the input. In the example on this page, we're saying the input you add 2. So the equation would be written as Y equals X plus 2. But something is happening to the X. It might be a 1-step, it might be a 2-step. You could be adding, subtracting, multiplying, or dividing. The other thing you need to be able to do is graph the ordered pairs from your function table. Okay, and then you should be able to connect the dots and tell me if they make a straight line, that it is a linear function. Okay, now we're to the Chapter 8 mid-chapter check on page 614 in your workbook. We are going to go through the answers so that you can check and make sure you are correct. You should try these on your own first. You hear me? First. So pause the video, do the answers first, then push play, and check to see if your answers are correct. You will have very similar problems to numbers 3, 4, 5, 6, 7, 8, and 9. You need to know the vocabulary, but there are not any fill-in-the-blank questions for vocabulary. So take notes and pay attention. And remember, if you turn this in to me tomorrow, you get extra points on your test. Okay, if you follow back in your book to lesson 2, you will find the definition for sequence. A sequence is a list of numbers in a specific order. For example, you could have 2, 4, 6, 8. Okay? This is an arithmetic sequence because every time that you move forward, you are adding 2. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. I could predict the next term and say 8 plus 2 would be 10. I could say 10 plus 2 would be 12, and 12 plus 2 would be 14. This would be an example of an arithmetic sequence. Okay. Now you also have to talk about a geometric sequence. So an example of a geometric sequence might be 2, 4, 8, and 16. And that would mean from here to here, you need to figure out what pattern is happening. Every time here, you are multiplying by 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so on. I should be able to list the next 3 terms in my sequence. 16 times 2 would be 32. 32 times 2 would be 64, and so on. Okay? Moving on to number 2. Fill in the blank. This goes back to lesson 1. What is the relation that assigns exactly one output value to one input value? And the answer to that would be a function. Okay? All right. Hold on and we'll go to the next one. Okay, so the next section, skills check and problem solving. Complete each function table. This refers back to lesson 1. So you have been given the function rule 2x plus 6. Okay, so they have given you the inputs 0, 1, and 2. So I'm going to say 2, substitute 0, plus 6. 2 times 0 is 0. 0 plus 6 would give me an output of 6. Next row, 2, substitute 1, plus 6. 2 times 1 is 2. 2 plus 6 is 8. Last input, I am saying 2, substitute 2, plus 6. I have 2 times 2 is 4. 4 plus 6 is 10. You can see it's kind of following a pattern. But I've completed the function table. I have my input and output. Later on, you'll be asked to use the x and y and plot it on a graph. All right, again, I have to complete the function table. I have the inputs given to me. I have the function rule given to me. All I need to do is complete the output column. So again, I'm going to substitute, and you should be showing me each step that you are substituting. Multiply by 0. 0 plus 1 is 1. Nice, easy numbers. Not a hard rule to follow. You do need to remember your PEMDAS steps. 3 times 1 is 3. 3 plus 1 is 4. And for the last, you have 3. Substitute the 2 plus 1. So you have 3 times 2 is 6, and 6 plus 1 is 7. So again, completed the output table. Next. Okay, going on to numbers 5, 6, and 7 on page 614. Identify the structure is the mathematical practice. The directions are to find the rule for each function table. And you're going to write the rule as an expression. So you have the input column. you have the output column. You have to move from left to right, going down the table to see. All right, 3, what's the relationship between 3 and 6, 4 and 8, 5 and 10? Well, it could be 3 plus 3 is 6, but 4 plus 3 would not give me 8. So let me go back again and try. 3 times what would give me 6? Well, 3 times 2 would give me 6. That works. Well, 4 times 2, that gives me 8, and 5 times 2 gives me 10. So for every single one of these, I'm multiplying the input by 2. So simply written as an expression, all I have to do is put 2x. I don't need a dot, parentheses, or anything else to show multiply. Simply the number beside the variable works. You should always put the number first, that's called the coefficient, then your variable second. For number 6, it's a little more complicated because this is a 2-step. So if you will take some time and play with this, you'll figure out for number 6 that you can say 1 times 4 equals 4, and 4 minus 1 equals 3. Check that out. It should work for 2. So say 2 times 4 equals 8, and 8 minus 1 equals 7. Looks very messy, so let's get rid of all that. And if I work through, we have the input, okay, times 4 minus 1. So that would be 12 minus 1. That gives me 11. So my rule must be, it's hard to fit that in that little spot here, but we're talking about multiply the input by 4 and then subtract 1, and that will give you the function rule for number 6. Okay, for number 7, again, this one is a little more complicated. It's also going to be a 2-step. You're not able to just multiply and go from 2 to 8, from 3 to 11, and from 4 to 14. Now, it would work to say 2 times 4 is 8, but 3 times 4 would not be the correct answer in the output column. I could try adding, because it is a larger number. I could say 2 plus 6 gives me 8, but that same pattern wouldn't work. 3 plus 6 would not give me 11. So, after playing with the numbers a little bit, you'll realize that 3x plus 2 will give you the answer here. Plug that in. Take the input of 2. 3 times 2 is 6. 6 plus 2 is 8. That's a check. 3 times 3 is 9. 9 plus 2 is 11. Another check. 3 times 4 is 12. 12 plus 2 is 14. Okay? All right, looking at number 8. Arnold reads an average of 21 pages each day. That is important. 21 pages each day. That's going to go together with the 21 each day, every day, per day. You should be thinking that you need to multiply there. So you're going to write an equation to represent the number of pages read after any number of days, okay? Now, you could use any letters that you want for your variable. You could say the number of pages that are read, P, equals 21 pages per day. D can be day. Okay? So the number of pages read equals 21 times D. That goes back to lesson 4. Okay. Again, finishing up with number 9, looking at some important words. The table over here, input-output function table, shows the cost of renting an inner tube to use at the Waverama water park. Okay, highlighted in yellow, I say explain how to write an equation to represent the data, because you need to explain your work. Then give the equation, and typically for the equation we're talking about y equals and something is happening to the x, some type of mathematical operation. Okay, so look at your table and see if you can figure out, well, 2 times 5 is 10, but it's not, I need 11. 3 times 5, that won't work there either. Okay, so it's not going to be times 5. All right, so try 6. 2 times 6 is 12. 3 times 6 is 18. So it's not going to be exactly $5 that I multiply by. It's not going to be exactly $6. It might work to multiply somewhere in between. Try 550. What's the difference between the output values, which are your cost, and the input values? As you go down the output column, what's the difference? $16.50 minus $11. It's going up by It's going up by $5.50. Okay, let's try writing that somewhere else. The cost is going up by 5.5. Same thing, 22 minus 16.50, the price has gone up. So we're talking about cost, so we're talking about price. So money, we're talking about it's going up by $5.50. Okay? So we should be able to plug that into an equation. All right, so we're saying y equals, the cost y, our output, equals 5.5x, the input. Depending on the input, whether it's 2 or 3 or 4, I'm going to pay 11 or $16.50 or $22. Okay? The input X, the output Y. Okay, I also wanted to go back. We went over this in class today, your quick check 8.2. So I went back to finding a rule when you had the position number listed in the table. Okay, it's a little different from when you are trying to find the sequence in a list of numbers. So a sequence can be shown in a table. The table gives you the position number in relation to the value. So you can write an algebraic expression to describe the sequence, and it's the function of its position. Okay, so I wanted you to pay attention to this and remember while we look at example 3. You will have it written like this on your test. Use words and symbols. And when they say use symbols, they're basically saying write an expression. Using a variable, using a mathematical operation, add, subtract, multiply, or divide. Okay, something is happening to the input. Now, they're talking about finding the relationship from the position on the top down to the value of the term. You first start with the position, then you go to the value. So what's happening here? Maybe it's 1 plus 2 equals 3. So 2 plus 3, oh no, that's 5. It doesn't equal 6. Must not be the rule. Let me try again. 1 times 3 would give me 3. Okay. 2 times 3 would give me 6. 3 times 3 would give me 9. So I think I found my formula. In words, my answer would be multiply the position number by 3. That would be writing it in words. Now, writing it in symbols as an expression would be, I'm going to go over here to the lined paper, and I'm going to say, well, they're talking about a value of n, so I'm going to use this as n. We're going to multiply 3 times n. So talking about the expression or the symbols, I would say 3n. Now, solving, I need to find the value of the 10th term. So that means when n equals 10. Now, the rule I'm applying is 3 times n, which would be 3 times 10, which would be 30. Okay, so I had to find 3 things. Words, I have to find multiply the position by 3. Symbols, I have to write as an expression 3 times n. I have to next find the value of the term in the 10th position. So when n equals 10, I'm going to substitute 3 times 10 equals 30. Okay, so good luck. That's a wrap. See you tomorrow. Miss Gregory signing out.